Good day everyone, we are group 2 and we're gonna report about magnetic deviation. So I am Cadet SIOPAN and I'm gonna explain to you first what is magnetic deviation. Magnetic deviation is the second commonly correctable error, this time within the ship, which is caused by magnetic forces brought by pieces of metal such as an engine or an anchor or what type of cargo the ship is carrying. Moreover, cockpit platters and other electrical equipment or wirings, if too close to the compass, can also introduce a compass error. So in other terms, magnetic deviation is defined the error inside the ship or brought by materials inside the ship. So the deviation varies with the ship's heading. We all know that. The angle of ship center line with the true north resulting to the deviation table as shown below. So as you can see in the table, we can use the curve to determine the value if the deviation on any heading. It may be necessary to interpolate between values. So for example, how to interpolate? So if we were to the point on the vessel on 11 degrees, we could be around halfway between 4 degrees west and 2 degrees west. So we could interpolate the deviation experienced on this heading. So if we interpolate it, we can get the value of 3 degrees west. So this is the deviation on 11 degrees, as you can see on the table as above. So the vertical axis states the correction of deviation in degrees, west or east, where east is again positive. The horizontal axis states the ship's heading or compass course in degrees divided by 10. Thus, when steering a compass course of 220 degrees, the deviation will be 4 degrees, as we can see in the table also. So note that the most sailing yachts, the deviation will be less than 3 degrees. So it depends on what type of ship are you in or what the ship is carrying. What type of cargo the ship is carrying. When steering a compass, it's installed if often shows larger deviation, and this requires compensation, carefully placing small magnets around the compass. But note, you can do only professionals or company representative can alter or can place small magnets to the compass. Conversely, a handheld compass does not have deviation table. Ideally, bearings should be taken as far from metal and electrical wirings. So that's all about what is magnetic deviation.
Good day everyone, I'm Cadet ASIS Joshua. I'm here to report about the correcting compass, which is variation in deviation. All information on a chart, including your own plotting, related to true north. Thus, all bearings on a chart are related to true north compasses. Point to magnetic north, which varies from true north by an error called variation. Compass also are subject to their own errors. This is called deviation. So in this paper, I'm gonna write a mnemonic rhyme, which is: to Vilma, my dear, Cecil at West. This is a pattern, so you cannot forget about how to get the compass or true north. So T stands for true north, and V stands for variation of. Variation is an error where you are on Earth. Okay, so M stands for magnetic north, and deviation, and D stands for deviation, and the deviation is created by a electromagnetic in your ship or some tools you put in your ship and metal. So and C stands for compass. Right now, we're gonna solve some problems. I'm gonna pull off some numbers on my mind so I can get through it. So assuming the true north is 68 degrees, and the variation, since I don't have a table of variation and deviation, I'm gonna pull some numbers in my mind as well so we can continue in solving this. Assuming that variation is 10 degrees west. So since it is west, we need to add the 2. "68 added by 10 is 78 degrees. So a deviation, since we don't have a deviation table as well, I'm gonna pull up some numbers on my head as well. Okay, assuming that this is 5 degrees west. So right now we can get the compass. 78 plus 5 degrees is equal to 83 degrees. So right now we get the compass, and if you want to get the compass error, we just need to get the true north and compass. True is 68 degrees, compass is 83 degrees. Compass best, error west. Compass list, error east. So what do you see? Compass best, error west. These two numbers is always subtract each other. So let's get through it. 5 2. I'm sorry. So 15 degrees error, since the compass is bigger than true, just like earlier I told you that compass best, error west, compass least, error east. So since the compass is bigger than true, this error is west, 15 degrees west. That's all. Thank you.
The magnetic course is the course after magnetic variation has been considered, but without compensation for magnetic deviation. This means that we are dealing with the rewritten equation from above, which is true course minus variation equals compass course plus deviation is equals to magnetic course. Magnetic course is only corrected for variation, and it is used for 3 reasons. First is to convert a true course into a compass course. Second is on vessels with more than one steering compass, also more deviation tables are in use, hence only a magnetic or true course is plotted in the chart. And the last one is bearings taken with a handheld compass often don't require a correction for deviation and are therefore useful to plot in the chart as magnetic courses. Please take note that the actual course lines the navigator plots in the chart are always true courses unless labeled as magnetic course or compass course. To summarize, we have three types of north: the true north, magnetic north, and compass north. And correspondingly, we have three types of courses: the true course, magnetic course, and compass course. All these are related by deviation and variation.